In example 8, we've been given a table of values for g and g prime. We've been given a graph of h, so we can see the slopes of h, and then we've been defined a function m. So m has been defined as g of negative 2x times h of x. And we've been asked to find the derivative of m at x equals 2. So in this case here, since we don't have anything directly relating to m, we're going to have to differentiate this m expression, to differentiate the notational form of this m expression. So it's going to look like this. So m prime of x, differentiating this notation, we're going to end up with g prime of negative 2x times, using chain rule, times 2 times h of x, and because there's this times in here, we have to apply product rule. So then we're going to end up with g of negative 2x times h prime of x. So this expression here is our derivative expression. So we're going to use this expression to find m prime at 2. So m prime at 2, okay, well, this is going to end up being g prime at, well, x is 2, so I'm going to put negative 4 into here, times 2, so I'm going to bring the 2 out front, times the h value at x is 2. Well, I can actually work that out. I'm going to highlight this here. So h of 2, I can get directly from the graph. H of 2 is going to be that point there, and that point is going to be at negative 2/3. So I can replace that h of 2 with negative 2 over 3. The g prime of negative 4, we also can get from our graph. So g prime, when x is negative 4, g prime is negative 1. So I can then replace that part with negative 1. And that 2 needs to stay in there. So I can start replacing these pieces with information from the graph and the table. So then I'm going to plug in my 2 into the negative 2x, so I get g of negative 4. Well, g of negative 4, well, there's negative 4, there's g of negative 4, so I can replace that with the value of g of negative 4, which is going to be 5. And then I'm going to multiply that by h prime. So I'm just going to use one last color here. H prime of, sorry, I'm going to write this in. So h prime at x is 2. So h prime of x is 2. Well, there's 2. And h prime of 2 is going to be the slope through that point. And that slope of that point is going to be, well, we can see that it has a rise and run of negative 1 over 3. Okay, so here the slope is negative 1 over 3. So then that represents the value of h prime at 2. So once I have all this, I can just calculate this all. I get 2 times negative 1 times negative 2 over 3. That's going to be positive 4 over 3 plus negative 5 over 3. And that gives me the value of negative 1/3. So there is the value of m prime at 2. So that's going to be negative 1 over 3. Example 9 comes from the 2014 exam, and again, we're going to have to do some stuff with notation here. It defines g as the function, the area under the function, starting at -3 to some point x, under the graph of f of t dt. So we've been given the graph of f of t dt. Okay, so this is our graph here. And we're going to use that to determine values of g. So in general, we know that functions are going to have some starting coordinate. In this case, it's going to be 0. And then the area under the curve defines that value, the y values for that g function. So g of 3 means that I'm going to start at -3. Okay, so my coordinate is going to be at -3 and 0. And using the area from -3 all the way to +3, let's switch colors here, to +3 here, okay, the displacement from there to there is going to give me the value, the y value of g at x equals 3. So I'm just going to split this up because I'm going to make this a little bit easier for myself to add up. So I know that those areas, the red area above and below, the blue area below, can cancel out. So I'm just going to work out the area pieces here. This is going to be a 3 by 4 triangle. So 3 times 4 divided by 2 is going to give me an area of 6. So that's going to be 6 in here. Okay, this area, which I'm going to highlight here with maybe green, this area in here, this little trapezoid, that's going to have a width of 1. It's going to have an average height of 3. So this area looks like to be 3. Okay, and then we can see that these little bits of area, this area in here and this area in here, are just going to cancel out. So my net displacement is going to be +9, so the g of 3 is equal to 9. Part B says h is a new function defined by g divided by 5x. Find h prime at 3. What that means is I need to differentiate the notation. And when I differentiate this notation, I'm going to have to use quotient rule. So that means I'm going to get g prime times the denominator minus the g undifferentiated times the derivative of 5x, which is just going to be times by 5. And that's all over the square of the denominator, so 25x squared. Okay, so finding h prime at 3, I need to find g prime at 3, times that by 5 times 3, which is 15, minus the g value at 3, and then multiply that by 5. And plugging x in the denominator, that's going to be 25 times 3 squared, which is 9. So 25 times 9 gives me 225. Okay, so working out this value then, the g prime at 3. Okay, so the g prime at 3 is going to be the derivative of g at 3, which is the same as f. So we can say that g prime of x is the same as f of x. Okay, so g prime at 3 is same as f of 3. So the f value at x is 3 is going to be given by this coordinate -2. So when I plug in these values, g prime of 3 is -2 times 15 minus 5 times the g value at 3. Okay, well, the g value at 3 we've already determined to be 9. So I'm just going to plug in 9 into that equation. So that's going to be times by 9. And then I can work out the rest of that value. So 225. The numerator becomes negative 30 minus 45. That's going to be negative 75 over 225. And that works out to be negative 1/3. Okay, so g prime at 3 works out to be negative 1/3. In part C, it says p of x is equal to f of x squared minus x. So we have a p function defined as an f function with an embedded x squared minus x. And it says find the slope of the tangent line of p at x equals negative 1. So first of all, the slope of the tangent line of p at x equals negative 1 means that we're trying to find the derivative of p at x equals negative 1. Okay, so that's what we're looking for. So to do that, we need to first of all differentiate the p function, and to do that, we need to differentiate the notation. So we end up with the outside derivative f prime, and then attached to that, because there's an embedded x squared minus x, I need to differentiate x squared into 2x and the x into minus 1. Okay, so now I have a derivative expression. I then need to find the value when x is negative 1. So I'm just going to plug in negative 1 where I see x is. So I get negative 1 squared minus x. So negative 1 squared is 1, minus negative 1 gives me an x value of 2. And then when I plug in negative 1 into the square brackets here, I get negative 2 minus 1. That works out to be negative 3. So what I need then is, I need the derivative of f at 2. Well, the derivative of f is equal to the slope of our f of x function. So what I'm looking for then is I'm looking for the slope of the f function at x equals 2. So when I take a look at the graph, at x equals 2 is this coordinate right here. And I'm not looking for the y-coordinate, I'm looking for the slope of this line. So I need to work out the slope value of that line. So the slope of that line looks to me, it looks like the slope is going to be a slope of negative 2. So I'm just looking at this triangle. It goes 1, 2, 3, 4 down, 2 across. That's negative 2. So then I can replace that f prime of 2. So slope at x equals 2 is equal to negative 2. And then that's timesing my negative 3 that I had calculated. So p prime at negative 1 works out to be 6. Okay, so there is the slope at x equals negative 1.